Welcome to the CRA-W Undergrad Town Hall event today. This afternoon, we're glad you're joining us. Today we have Taghrid Samak from Google, and she's going to be talking about using machine learning for network capacity management. So we're going to talk a little bit about some logistics first so that you know how this is run. At any time during the webinar, you're welcome to ask questions, and the way to do that is through the question and answer box here on the right bottom. Just type your question in, and either the speaker or someone behind the scenes will answer your question as we're going. And so we really encourage this to be somewhat interactive with the questions. The next thing we have for logistics is we are going to have some polls throughout the webinar today. And at that point, when the poll opens up, you'll see the slide with the possible answers. You don't want to click on the slide. You want to click on the poll over on your right-hand side and answer. And it'll be a couple seconds until we get all the results in, and then we'll go on from there. So we really encourage you to participate in the poll so we get some of your feedback as we're going. So today we have Taghrid, and she did her PhD at DePaul University and is now at Google. And what she does there is she's applying statistical modeling for diverse network applications, from capacity planning to wireless networks. And so we're really happy to have her today. I'm not going to read her bio. She's going to tell you a little bit about herself. So Taghrid, I'm going to give it over to you.
Thank you, Lori. It's really my pleasure to be here. So let me start with a little bit of background about where I am or who I am. So I grew up in Egypt. I spent all my young life there. I actually did my undergrads in Egypt in computer science, Alexandria University. I moved to the U.S. for my PhD in 2005, and I've been here since then. I finished my PhD at DePaul, as Lori said, and during my PhD, I did mostly network configuration management, so mostly using, again, sort of a machine learning, but still analytical techniques for configuration management and traffic analysis. After that, I joined Berkeley National Lab, which I also did data analysis, but during that time, I was kind of a more general data scientist kind of role, where I work with biologists, I work with physicists, so mostly diversity of applications. And actually, for the past 4 years or so, I've been a part-time law student at the University of San Francisco. So if you have non-CS related questions about how life as a law student is, if you're now undergrad and you want to switch careers, not saying that I'm going to do this, but feel free to kind of ping me with those questions. So we have two parts, as you know. So we're going to talk a little bit about some work I'm doing here at Google, applying machine learning for some of the network analysis problems we have. And at the end, we have some of the mentoring pieces. But let me start by kind of talking to you about a data scientist life. I'm sure some of you are kind of picking what you're going to be after finishing your undergrad, or if you've taken some classes in data analysis or statistics, and you're thinking what a career in data science look like. So this is kind of my day-to-day life here. So there's three main things that I think about every day at every task and every problem that I have, like what's like data, the knowledge action. So let me explain a little bit. So we all know what data is. So this means you're collecting tons of information from whatever application you're dealing with or whatever problem you're handling, and you want to learn something from it. So you want to build some knowledge out of this data. But you also want to make sure that what you're learning from the data has value, and you can take some actions to kind of solve a real problem. So this would be like if you're in a business intelligence area where you're kind of getting performance indicators for an organization. If you're doing some technical work and you're building a web application and collecting data about your users or your application, how it's going. If you're in social networking, any area that collects data, you want to take actions, intelligent actions based on those data. So in most of, usually this is the first thing I think about. You start with what's the question you're trying to answer, and then build your way to, okay, to answer this question, this is the type of data that I need. And then you start the process of, do I have this data, or do I even go collect it? So you think about collecting the data, cleaning up the data, making sure it's high quality, and you're making sure that you collected the right thing to answer the question. And then comes the interesting part of kind of iteratively working through some algorithms and methods and optimizations to build this knowledge that will help you take the action you sought out to do at the beginning. It might become clearer, a bit clearer once I go through some of the problems or as the presentation goes along. But this is basically how I spend my time, looking at data to kind of clean up, verify, collect, thinking about what the question I want to answer is and how to frame it correctly, and then building the knowledge. And this has a lot of kind of coding, mathematics, communication. So it's not just about building the mathematical model. You also want to make sure that the results are meaningful and you're reporting them correctly for people to understand. So with that, let me start off some work here that I'm doing at Google. So I'm part of the corporate networking team, which means our bigger team manages Google internal network, connecting the different offices, managing the network inside the office. And you don't have to know networking background. I'm going to give you a little bit of a background on what we mean by capacity management. That's why I'm going to sort of explain to you what we mean by capacity management. And also, if you haven't taken machine learning class, that's fine too. I'm going to just explain briefly, high level, what the techniques we're using are. And then I'm going to go deeper on one use cases here from Google corporate networking. So again, I'm going to talk to you about what data we're collecting, what knowledge we're building, and what's the action that the business needs from us to kind of do the analysis. All right, so if you're connecting to this webinar, so you're probably on a network. Let me just start by this. If you're home or if you're at school, you're either on the left side or the right side of the slide. So the left side, if you're home or in your dorm, you have your laptop, you might have a printer, you might have like a phone who's even connected to the network, you might have a desktop computer. All of this is connected to a wireless, a router, whether it's wireless or wired. And eventually you get a subscription from your service provider to connect to the internet. So that's your home network. Take it a little bit further, a bigger network like on like a school campus or an office building, it's exactly the same. You have terminal nodes, which your laptops or your desktop, these are the workstations that people use day to day. That's my end point. And then they're connected somehow to through some networking components, whether it's switch at this first level or router that kind of aggregate or group everything through your connection to the internet. You'll have some people using desktops, some people using laptops, and it's all somehow connected. Almost everyone has a firewall for protection that monitors the traffic and makes sure nothing malicious is happening. But eventually, to connect your office to the internet, you need also a subscription through an internet service provider. So an enterprise network is actually a group of those office networks, like different buildings, different offices, and they're connected. So what is capacity management? So think of it like you have different components in the network. You have they're connected through one way or another. They have certain connections, and you want to make sure you're managing all those resources efficiently. So you want to make sure at home you want to buy the subscription that will enable you to browse the internet, do your internet searches, and also browse Netflix without interruption. So that's why you buy the bandwidth that will satisfy your needs. On an enterprise network, we want to make sure for each, we pick the right components, which routers we're using, what vendor we're using, which company we're buying those routers from, which desktops we're using for our engineer to do their job. So this is like we're buying the right components. And within the building, how are we connecting those components so we don't have high delays for certain users over other users? When we have a web meeting like we're having right now, there's no interruptions. When people are uploading or downloading their work data, it's fast enough. So you're doing the office design internally to kind of meet those needs. So you're managing the capacity in that sense. And the last hop would be when you connect to the internet, how much should you pay for and how much should you buy for your office to be connected to other offices and to the internet? So really, capacity management comes at the different layers or different levels, whether we're buying the right components that can handle our traffic, we're connecting them in an efficient way to handle our services, and we're buying the right connectivity to the outside world. In a visual sense, this is what you might see. So to give you a little bit of background on the terminology, if you run into some of those terms, you'll know now what they are. This is the same figure from the previous slide. But on the internet side, when we talk about connecting different offices or different buildings, this is wide area networking. And the building connection to the internet is also wide area networking. Anything that happens inside your network is local area networking. So within the office, the components, the wires, even the wireless routers, this is all local area networking. So you could do capacity management from your office to the outside on the WAN side, or you do capacity management on the way you're actually connecting the local network. At the last level, which is actually the first thing that the users see, or is how they access the internet, whether they're using their laptop or a desktop. That's the access layer. The very first point that when our employees go to work, they access their laptops, they open up their machines, they connect through the access layer. That's the first user's point of connection. And that also has some components in capacity planning where if it's a wireless connectivity, how do you place the wireless access points and all of those things? How do you place the switches so you're not penalizing some users and being in a different floor than the other, so things like that. So with that, as you saw, we have different points that we manage in terms of capacity. So we also want to collect data that will help us answer capacity questions. So in an enterprise, you want to make sure that the users are running the right applications and they're running it efficiently. We have the right network design, how the components are connected. And we also want to make sure that when we subscribe and pay for connectivity from our offices to the internet, we're not paying more than we should. And how do we know this? By monitoring how much we're actually using of the bandwidth, and seeing how negotiating contracts from service providers to kind of give us, okay, the right price for what we actually need. And one big area in network data analysis is when you have all those components in large networks, you want to make sure that when a problem happens, you have the means of detecting it and correcting it. And what better way of doing this than actually having data? So you collect the data, and when a component fails, you want to collect data, or you have the data to know why it failed, or is there a way of preventing this failure from happening in the future. So we can predict, we should be able to predict performance, we should be able to see what's happening for each application, and we'll be able to kind of negotiate right prices for when we buy capacity from other vendors. All right, so to answer those questions, we kind of want to use machine learning because we have lots of data, and it's better to kind of have the machine do it than us kind of sifting through terabytes of traffic data, especially that we have a really large network. So I just want to get a sense of if you've taken a machine learning class, if you use machine learning, and this is in a general sense, even if we had a statistical course to kind of use one approach or the other. Or maybe this talk will encourage you to actually take some machine learning classes or networking classes as well. And actually, to get you some sense, so I did my PhD in it's computer science, but it's in networking, and I ended up taking machine learning classes. And with that was my actual job. When I got the job at Berkeley Lab, it was for data analysis. Networking was one of the applications I worked with, but it was the general knowledge of machine learning that helped me through both jobs at Berkeley and here at Google. Oh, wow, that's nice. So, so good. So we have people who've heard about it, so that's good. Applied it, that's nice. So I think the coming few slides about background machine learning will be kind of more easy for some of you, so that's good. Thank you for participating in the poll. So I kind of picked those two definitions of machine learning. So the first one is Wikipedia definition, which is basically what everyone thinks about machine learning, even non-technical people, is kind of teaching computer to do stuff, right? So they learn things without actually being programmed for those things. But for us scientists or computer majors, we kind of think of it as the Tom Mitchell definition. Which, well, I love his book on machine learning. That was the first book I read on machine learning, so I kind of highly recommend it. So it's kind of more of the science of machine learning is learning how to kind of build the algorithms, improve the experience, automate things. So the fundamental laws that actually govern this learning process. So it's easy to say, I'm going to teach the computer to do this, but then you have to kind of build the fundamentals that will kind of enable you to do this correctly or efficiently. So first thing that you hear in machine learning, oh, do we have data? What's the data? Where's my data set? What do I do? So data is the key central thing in machine learning. And if you think about it, a data set, or when people say data set, this is what they think about. It's sort of a table format kind of data where you collect some observations about something, so for example, you have student data, you have like address, GPA, classes, all of that. So your observation or your object of interest is the student, but then you're collecting different features or attributes for that student, like age, address, GPA, classes. So you have, in a sense, this table sort of similar to a database table. We have multiple observations. These are your rows, and then for each observation or sample or objects you're collecting, or you have different dimensions or different attributes. And in most machine learning literature, it will be called feature, but you use dimension a lot when you're talking about the mathematical formulas for that. Attributes is really, and measurements is really, they're more used when you're talking to people who do experimental analysis, where they're collecting samples from soil and you want to measure things about those. Variables and fields are coming from the database context, which is used here as well, and variables also from the mathematical sense, where you're predicting a variable based on other variables. What's your independent or dependent variables? But they're all, from a data set perspective, they're all the same thing. So what's a typical workflow? Ideally, I would love to have this table with everything clean and everything, no missing data. I have all the information I need for all students to kind of do some analysis. But then if you're in an area where you actually you work with biologists, you work with environmental scientists, data collection is a big deal because you're not controlling the environment completely. You're collecting data from things you can't control. So data collection has to be a process of its own. You do a lot of sampling where you don't have enough capacity to kind of hold every single data point. You might want to scale your data sets to kind of fit certain ranges. So a lot of pre-processing comes into preparing this data set or this table for actual analysis. A big part of it, or one of the terms that you're going to see a lot in machine learning, or two terms, feature extraction and dimensionality reduction. And feature extraction is the way of, in the basic sense, what features are most useful to answer the question that I want. And you could be doing this manually or based on domain expert. For example, in networking, I know I will have to connect the packet count, session information, things like that. In biology, they have, for a certain problem, they have to use the XYZ. And sometimes if you've collected a lot of data, lots of dimensions, you might end up not using all of them. But you need to make sure that you're selecting the right type of dimensions, and this is where dimensionality reduction with feature extraction happens, where you want to make sure if you're reducing the data, you're keeping the right information in the data. And then you start the learning process. So learning the model, which is building the knowledge from my very first slide, to try to build the knowledge, and this is an iterative process. You train the machine, train, and then you evaluate. You keep training and testing. And then when you have a satisfying model, or you feel like you have the right knowledge now, you use the model. And this is your action piece. Do you want to do predictions on something? Do you want to do just reporting on what the data looks like? So it's all iterative process. And things might change where you have learned something and you go back and say, oh, we were missing one important feature. Let's go back to feature extraction and collecting more data. So in a sense, or more formal definition would be, if you have this data set of all observations and features or dimensions, can we find a function, a mathematical function that accurately fits the data? And with that, it's not, this is a very, very high level description of it. But that's what kind of decides which machine learning method you're going to use, or what problem space you work in. So your problem could be fitting for some algorithms, but not others, based on the question you want to ask. So there are different types of learning methodologies. Here I'm just going to talk about supervised versus unsupervised, but there's so many more learning methods. Supervised is where your function is, you're trying to kind of establish a function that predicts one feature from the other. So you have one feature of interest, and you want to use the other features to predict it. For example, you want to evaluate how the location or where a student grows up would affect their GPA. So you have the GPA is your feature of interest, and you want to predict it from the other features, whether it's like where you grow up, your age, all the other features you're collecting on the student. So that's supervised. You have sort of a label or something of interest. You're labeling students by GPA, or you're labeling by other feature, and then you want to use the rest of the information to predict it. For unsupervised learning, it's more like kind of not clearly defined. You don't have labels. You have like a bunch of data, and you want to discover whether there are groups that are similar. Again, back to the student example, you want to just group students based on their information, how similar they are. So you could be like one group of students with a high GPA, who took these classes, things like that. So you want to just discover patterns in the data. And then, again, you go back to the process. So you need the data to do this. You need the set of functions that you want to try, the mathematical functions you want to apply, and depending on the question you're asking, whether you want to predict something from the others or you want to just discover patterns and do data exploration, you're going to go through supervised or unsupervised. But within that, it's iterative. You training and evaluating the error, train and evaluate the error, so that's an optimization process. All right, so this is just a visualization of kind of re-summarizing. Supervised learning on the left side is if you have those dots in the two-dimensional space and you want to predict which one is blue, which one is red, and your function is, you need to figure out this straight line. So the equation of this straight line is your mathematical function. Whereas in unsupervised learning, which is the one on the right side, you have just a group of black dots and you want to see which are similar in space or clustered together. So the algorithm would give you a group of two clusters. These are the right and the left. There's no labels here. So this is just a kind of quick formalization of what we just talked about. So if you have your table, again, cleaned up, data collected, filtered, and everything, and you have variables of interest. So you have your x, x1, 2, 3, and you have your labels y1, y2. These are your variables of interest, and your goal is to build a function that would map x1 to 3 to y1 and 2. So your labels or classifiers. So this could be whether you're predicting a number like the GPA, or you're predicting a value true or false, success or fail. And in most cases, many algorithms only support one predictor, but some of them support multiples. So you have to think of, am I predicting something from the rest of the observation, from the rest of the dimensions? Or on the other hand, is the unsupervised, where I have all the x's, they're all the same. I don't have one special x that I want to predict. So just learning about patterns, maybe observation 1, 5, and 6 are very similar, but 2, 3 are another group. So your learning pattern, and unsupervised learning is used a lot in initial data exploration. If you don't know what's in your data, so you do clustering. And it's in many cases when people talk about data mining, it's mostly under the unsupervised learning realm. Clustering is the big area of algorithms that kind of cover most unsupervised, or a lot of unsupervised techniques.
And that's for only.
I'm sorry, do we have a question?
I'm not sure what that was. Just go ahead.
All right.
I'm not sure what happened there.
Okay. So as I mentioned, so you start with your raw data, and then you kind of go through different iterations of learning. So you split your data for which part you should use in the training, and then you train multiple times on different parts of the data, so you're not approximating a function that might give you the wrong error. And you keep kind of doing this until you hit an error threshold that you're fine with. And error thresholds that kind of ends up your training are usually set by domain experts, because every domain is different and every data set is different. And then, but as you're training, you want to, at the beginning, hold on to a smaller subset of the data that you don't use in the training. So you split your data into two buckets. One of them you give the machine and you build the model, you build the knowledge, and then once you have a model that has good error values for the training data, you use the validating data to make sure that, oh, if a new data set comes in, is the model still good or bad? And then you go through multiple iterations as well. So in our network, we collect a lot of data sets, and one of the questions we want to ask is what our users are doing with the data. So if I want to ask, if I have collection of different application information that each user is using, and I want to just discover user groups, similar users based on the application profiles, do you think this is supervised or unsupervised? And think of the table that we had in the previous slides, whether we have labels or not, or the information the same or not. And sometimes the question comes clear and easy to kind of say whether it's supervised or unsupervised. Sometimes you need to meet with your customer multiple times before even you identify the question of interest. So the third area of machine learning that you might have heard of is reinforcement learning, and this is mostly kind of a more direction, more related to general AI, where you're teaching an agent to do something, where like when you're teaching your dog to do something and you give it a treat when it does something good and then take something away. So that's kind of your reinforcing behavior. So that's another area of machine learning that you might kind of consider. All right. So it is unsupervised the way I described it, but I could see why some people thought it's supervised. And this comes back to, actually, this was a trick question, because the way you define the question is key in machine learning and when you're applying it to real problems. Because if you don't have the right question, you might end up using techniques that are completely irrelevant, and you end up not answering a question, costing the business money, or wasting your time. So I kind of meant it to be unsupervised, but I can see why some people thought it is supervised, because if you're actually predicting for a specific application, then you have a label. You're predicting the application from the user profile. So thank you for kind of reinforcing my point. So let me talk a little bit then. So now we've covered what is capacity management, what machine learning can help with generally, and now I'm going to talk about a specific example that we've been working on here at Google Corporate Networking, which is WAN capacity forecast. Remember, WAN side is where for each office we're connected to the internet, so we actually have to pay an internet service provider for this capacity. So, and you see here, this is the map of all Google offices as of 2016. So we have a big network. We have so many offices, and we want to make sure that what we're paying, what we're subscribing for is enough for our employees to do their job, and also we're not buying more, like a lot more than we need. So otherwise we're going to be costing the business more money than it should. And each office has its own internal LAN design that might be different from the other offices, so this might actually also affect how traffic comes out of the network to the internet. So again, so the question we want to answer, again, I'm starting from the action. What is the action? We want to make sure we're paying the right amount of money for our connectivity. And then we think about, then, we want to predict the bandwidth usage for each user or for each office based on what our users are doing. So what do? We want to collect the right data to answer this question. So what we do have is historical usage data from previous years. So for each office, we have data from how the bandwidth was used by this office for the past 2 years. and it's collected by SNMP. You don't have to worry about this. All you need to know is that that's the protocol we use to collect network data, in case you're taking a networking class or someone mentions it to you. So we do have historical usage data, global for each office, how much data was used, how much bandwidth was used by this office. And we also do have information on how many people are sitting in this office. That's our employee headcount. It comes from HR. You don't need to know more about it than this. And our mathematical function is we want to predict bandwidth from headcount and time. So our variables are basically three variables. We have bandwidth data, we have headcount, we have time. So now time is a variable as well. So it could be any diversity of features. And our label or a variable of interest is the bandwidth. And we want to build the mathematical model that taking a specific time and a specific headcount, what the bandwidth should be. And the way we use this is, as I said, just to kind of summarize, we collect bandwidth usage for the past 2 years with the headcount for the past 2 years. And then we feed in the headcount for the coming 2 years and let the business know that for this new headcount, for this office, this is how much bandwidth you should buy. So do you think this is a problem for supervised or unsupervised learning, the way I described it in the previous slide? And this might be a bit clearer than the previous question, so can I have high confidence that you'll get this, or you get what I meant for this one? Again, think of the table we talked about, whether you have a special feature of interest, whether you don't have a special feature, are you creating grouping? So again, when you hear the word prediction, it's mostly supervised learning. Or not. Let me see the poll results first before answering. So remember the question we had before was grouping based on applications, and it was more unclear. Oh, nice. Okay, so that actually this was meant for supervised learning. And I can see maybe you want to group users based on their usage pattern, and then it might fall into the unsupervised learning realm. But since we explicitly said we have a function, so we're predicting bandwidth from headcount and time, then we have a variable of interest. So just to clarify again, so we use headcount and time from previous years to predict the bandwidth. And in the coming years, we look at, okay, so what's the future headcount is going to be in that future time, then we predict the bandwidth. That's why it's supervised. All right, and as I mentioned, it's a long process. So we have historical headcount and historical utilization. This is our training data. And it takes a lot of effort to kind of prepare the data at the right level. For us, for example, historical utilization is coming at a 2-minute sample, while historical headcount we get from HR as a monthly interval headcount. So you need to align your data to make sure that each sample is kind of makes sense to put two variables together. So you do some data alignment. If you're missing some data, you do interpolation. If your data is really highly variant, you would want to do some smoothing if appropriate. And then so now we identified it's a supervised learning, but within supervised learning, there's a lot of techniques you could be using depending on whether your features are numeric or categorical or any other type, even if you have kind of like a object feature, images. So you kind of pick the model or the way to learn or the learning algorithm based on the data. So for this example, because it's all numerical and it's we're predicting a numerical value from other two numerical values, who use regression techniques. We use non-negative least square because it kind of maintains that all variables are positive. So you kind of have to think of those things when you're picking the algorithm. Again, we do multiple models, we cross-validate models against each other, and then at the end, we predict for future values. So the next slide is going to have a quick kind of view of the results. If you focus on the left side of the left panel. So this is an example of an office, and we use data up to 2015 to learn what the utilization will be up to 2017, starting 2015 to 2017. So if you just focus on the left slide, and I know you're going to notice there we don't have actual numbers because it's confidential data. It's not that we're missing the actual numbers. So we're using usage data and headcount up to 2015 to build the model. So the dotted lines are actually what the model had predicted. So if you look at the headcount on the top left and the dotted lines on the bottom, you can see, like, intuitively, we know that our employees in this office are going to grow. We're hiring more people. The people, when you hire more people, they're using more bandwidth, so we're expecting it to be higher, and the model picks up the trend nicely. The right side is kind of different because this is an office where in 2014, a lot of people moved out to a different office, and then the office kept ramping up back again with new people getting hired. And you want to make sure that the learning method you've used is going to pick up this trend as well. So you could see it nicely that when the headcount dropped, the actual usage in 2014 also dropped, and the model kind of approximated it nicely until 2017. So you want to think about all of those things when you're picking the training method that you're going to use. With that, I think we are done with the research part.
Yeah, thank you. That was great. So we have time for one question that was asked. One person asked, how did you get interested in machine learning?
So it's kind of interesting because I think I mentioned it briefly, but I didn't set out data science was not a big hype at the time when I did my PhD. So my advisor worked in network management, and at the time it seemed interesting. So my husband and I moved to the same university. We worked with the same advisor, so it was a more social decision to join DePaul and work on this problem. But at the end, I ended up doing a lot of analysis. So I kind of tended to, whenever we have a network problem or a configuration problem, I tend to think about what data can we do to solve this problem. And taking a machine learning class at the very beginning of my PhD was really, really a key point where I did my class, and then I kind of transformed into, okay, using data to answer most of the questions. I also took master's classes back in Egypt, a lot of pattern recognition classes, and I had a very good advisor who did computer vision, so it was most of on the unsupervised kind of learning methods. He was an image processing person, so I kind of read a lot about that. And then when I joined DePaul, I took the machine learning class. My advisor worked in network management, so I did a lot of data analysis to answer network management problems, and then end up actually loving data analysis. I don't know if that answers your question, but that's how it happened for me by, I think, opportunity, so to speak. I didn't kind of plan ahead that I'm going to do my PhD in machine learning because I'm actually on the applied side of it. I don't develop algorithms. It's more the practical side where I talk with the users. I have a customer that have a problem that would need data analysis. We go collect the data. We apply machine learning, not develop the algorithms.
Mm-hmm. That's great. Okay, so we are short on time, so I think we should just move right into the mentoring section.
All right. Okay, so I came to the U.S. in 2005. I did my PhD at DePaul, and then I joined Berkeley Lab and then Google. And throughout all those times, I kind of had like my main focus, and I would also do something else. So let me get a feel from everyone what you think about extracurricular activities, whether if you're in school, do you practice sport, do you volunteer at social clubs? What do you think of, what does extracurricular activity mean to you? Because similar to like my involvement in machine learning, it's also about opportunity, whether you have the opportunity to actually do those activities or not, and what it means to you as well. And we're going to talk about some of the things that you kind of think about when you're maybe volunteering someplace or doing something extra. We'll talk a little bit about time management as well, but there's a lot of like many disclaimers in this area on what I think is good time management strategy is, or what works for people might not work for others. All right. Great. So I have a mix of people. Okay, I stopped playing basketball in high school too. So yeah, sports was not yeah. So that's good. At least so again, this section, like the mentoring section in general, or if you're getting advice from anyone, you cannot take it with a grain of salt. What worked for some people might not work for you. So you have to think also about your circumstances and context. So you find your own pace, your own balance, what works for you, what you're comfortable with. So the coming few slides are going to be more of anecdotal advice about what worked for me. And I should also make a disclaimer that up to 5 months ago, my view on the world was different because I just had my first babies. So I have twin boys. They're 5 months old now. So maybe I'll have another version of these slides when they're a little bit older. So that's a disclaimer as well. What I did in school, if you have kids or if you have family that depends on you, is completely different. I've been married for 13 years, but again, my husband and I work in the same field. So that also makes a difference when you're organizing your time. So just, again, what works for me might not work for you, so just kind of take a step back of any advice you take from anyone and just kind of think about your own circumstances. So to give you an idea of why I might have something to say on this topic or not. So as a graduate student, I kind of volunteered a lot at DePaul. So I was part of UPE, I was part of ACMW DePaul chapter, so hence like, yes, the computer science clubs and organizations. So I would have clicked option D as well. I also volunteered at the Egyptian Student Association, so because I grew up in Egypt, I moved here in my adult life, so I kind of still have ties with Egypt and I care a lot about what's happening there. So I take some initiatives to kind of volunteer for even now. And as you move from school to a professional life, you find like your passion is still kind of the same. You maybe volunteer for the same organizations, but with more capacity. Now you have more experience, you mentor other people. And that's what sort of happened to me as well. So I kind of try to volunteer when possible for women computing organizations. And also about the opportunities of you have your student clubs. Here we have at Google, for example, we have diversity initiatives. So you try to kind of align your work with your passion for extracurriculars as well. So we have I try to help out when I can within Google. And for the past 4 years, actually, law school has been my extracurricular activity. So I kind of like, okay, I managed to keep my scholarship, yay! And if you go into research, you'll get an opportunity to actually serve on a committee for technical conferences, like reviewing papers or putting together the conference event. So this is another opportunity you'll get if you go into graduate school, or maybe if you're involved in research as an undergrad, that's also something that you'll find. So with that, let me just say, okay, extracurricular, what does it mean? It's something outside of your normal realm, but then what is normal anyway? And what's normal for me is not normal for other people. So as a student, you have your schoolwork, that's the main focus, but you could also be working full-time or part-time to support yourself, support your family, so that's your normal. Anything outside of this is something extra that's really, you commit for it, but it's not really something you get penalized for not doing. Student organization, service to other. As a professional, the extracurricular activities are not going to change much. You still have your workout every day, your nonprofit, your mentoring. What changes your normal is your full-time job. And also, if you have a family, that comes part of your normal life, where you get your focus first and your priority is getting your job done. As a student, you get your classwork done, and then you think about other things. So for me, how I choose my extracurricular activities is where my passion is. It has to be something you really care about. Like I saw some people say like service to others. So if something you really care about, that's the best way to kind of do something extra. So if you don't pick something that you're passionate about, you're going to end up not doing a good job. And if you're spending more time on something extra that you don't care about, you're probably going to hurt your job too. So for me, I kind of volunteer when something happens, when I'm needed to mentor maybe women in technology. I do that, and I do this I did it throughout kind of like since I graduated. Now that I have more capacity to do this and help out, I try and do it. That's because it's something I care about. The other thing that if you commit to something, if you care about education and you want to volunteer tutoring students or in underprivileged communities, you have to kind of commit. The reason you have to kind of think about it, and it's going to come up in time management slides as well, is that all of those things, service to other or organizations and clubs, they depend on volunteers. If you say you're going to commit, you have to do it, because if all volunteers are not showing up, nothing is going to get done. So first thing, follow something or commit to something, or pick something that you really care about, so you do it happily on the weekend, or kind of stay up at night to finish this conference thing, because you do care about the issue. And the next thing is, once you commit, you have to follow through. Even if sometimes you won't find the time, or something will come up in school, you have this late assignment and you couldn't make it on time, let people know. Other volunteers understand, and they're all there to support this cause that you all care about. So just kind of make sure that you communicate this well. And for me, it has been really a kind of great experience volunteering for all those things, because it helps me, again, things you care about. At least even if it's a very small thing you do, you put an hour a week to do something, at least you'll feel that you contributed. The other thing is the people you work with. Sometimes you might volunteer in an organization and then you find out that you're not comfortable, you're not enjoying the work, not because you stopped caring about the issue, it's because you didn't like the setup. The people are not on the same value system as you are. So you have to think back and kind of say, all right, so do I really want to deal with all this extra overhead of dealing with the people because I care about the cause, or is there another organization that might align more with my values? So you kind of pick both. You pick the cause and you pick the community you're going to work with. Or maybe you have enough capacity to actually go in and change the process, or kind of help people understand your views. Go for it. But for me, it's building those relationships that kind of matters to me as well. And you get a lot of professional benefits as well with that. You build your resume by putting all those things that you kind of did outside of your work. It shows that you have broad knowledge of things. You're a well-rounded person where it's not just about the job. You do well on your job and you care about other people. And in addition, you're learning a lot of skills. If you're in a very technical field and you will get a job as a software engineer, having managed this event for your student club helps you do some program management kind of skills, or product management. You took the minutes, you organized people, you made sure everything is on time, on track, you followed through. So this kind of building your skills, not just as just a technical piece of your degree. And again, it's all about gaining more experience. But once you start doing all those extra things, you kind of have a lot to do. You have your studies or your work, you have things that you've committed to, and then you realize, okay, I can't do all of this. Hence comes the time management piece of my mentoring slides. And I want to get some sense of from people, how do you think you're managing your time? And also think of it like time is a resource. You allocate time as you need to do things. So you could be kind of spending more time on this thing right now because you have some reasons to do this, or you're putting less time for your extracurriculars because your family needs you. It's all part of time management. I'm not saying time management means you have to do everything equally with the same capacity all the time. And we're going to talk more about skills or kind of strategies for time management in the coming few slides. So don't think of it that I'm not doing anything else, then I'm not doing time management. You're probably better in it than you think you are. Yeah, we have people all over the world. I think this is a very reasonable response to this poll. Like people all over, like I think I'm good, I think I'm. So some people don't really realize it, that they're good at time management. So if people who said really suffering, don't think you're really suffering. It's not just you're not realizing that you're doing all these other things. You just kind of have to kind of step back and think about it and see where you can be more productive. So let's look a little bit, again, this is a personal experience thing, and I'm not putting emphasis on areas, like they're not all the same. So let's see. For me, I kind of do some prep work for time management. I try to kind of make a to-do list of everything I want to do. So first thing is kind of clear and focused goals or tasks. Even if I'm kind of say, oh, in this month I need to kind of finish this code or this analysis, I try to kind of type up the small pieces to be able to work on one small thing at a time in my to-do list. At least it gives you a sense of satisfaction when you cross even the small items from your list. And be sure that when you're writing those list of goals or tasks, they're going to change. Even from day to day, something will come up. Focus will be moved from this assignment to the different assignment. So just be mindful when you're writing your to-do list that you're reviewing it now and then, even every day, if it's like work-related, if it's school-related. Just look up your to-do list every day and see, oh, yeah, maybe I shouldn't do this today. Let's kind of revise this and be flexible. And one thing that I've learned, and all of us learn it the hard way, is learn to say no. Sometimes you've volunteered for a long time for a certain cause, and people will know that you care about this, so they're going to approach you every time they have something similar. And it's okay to tell them, well, I'm busy, I can't do it, but keep me posted with new things. So just don't close the door. Like, learn to kind of reject politely and say, all right, that's fine. Let me get back to you, even if you don't know for sure if you're gonna make it. And this happens with time. You're gonna learn what your areas of strength are and things that you can do more productively than other things, where you can say yes because you know it's going to take you a lot of time, but sometimes you take on something that's bigger than you think you can handle just to learn, so that's good too. And for me, I try to kind of prioritize my to-do list, whether it's by value, things that, for example, at work, things that matters to my organization, things that are going to put me in a good position with the leadership, or I can prioritize by how much time I'm going to spend finishing those tasks. So if something is not going to take me a long time, I could kind of get rid of it quickly, or I could leave it until the end because I know if I come into a time crunch and I'm running out of time on other things, this could be done quickly. And one of the big prioritizing factor in all of our lives is deadline. So things that are due tomorrow, well, this is what I'm going to work on today. It's not an option. And the trick is to kind of figure out which things you want to evaluate their priority by value or time or deadline and work out your own system. So once you've done this prep work, this is what kind of I try to do. I'm not saying that I do this in every single task I have, but things that I want to think about. I usually plan by priority. So you work out your priority system and then you plan ahead. And I like to actually do a daily to-do list. Every day I come into work, I know like from 9 to 5, this is what I'm going to do. I try. So again, it's all about kind of being flexible too, because like you would plan your work ahead. You're going to classes, and then after class, you're going to finish this specific homework, and then your mom calls, oh, I need to be picked up to do this. So you kind of change your day-to-day life. But you also want to set up your planning short and long term. Like this week, I'm going to finish this program or this software engineering assignment. That's fine. Long term, in 4 years, that's what I had planned. So 4 years ago, I said I'm going to be done with law school in 4 years. It's a part-time program. I can do it after my job. But then 5 months ago, I had my baby. So for the past year, I was kind of preparing for them to come in. So now I'm kind of like I pushed some of my papers due for one semester. And so all my friends graduated in summer, but then now I have like more time to finish. So don't think that kind of like the goals that you set or the time that you set for a specific task, this is it, it's final. Things change and you have to set up your priorities. So now my babies are the high priority for me. I need to take care of them. Family is important. Although I was very, very passionate about law, and I'm still passionate about my law school, this can wait because I can still get credit in for those classes, and I will graduate eventually, but not in 4 years. That's fine too. And then you think of execution, and I know like this is probably easier said than done. avoid procrastination. I know we all do it, but it's something that just keep in your mind. Like if you get an email and you think like you're gonna answer it right away and you know what you're gonna say, just do it. Don't wait like, oh wait, don't, unless you're angry. So just that's fine. It's fine to wait if you're angry. And I know a lot of people say multitasking, they can multitask, and I doubt it, and you could look up research on this. Just make sure that when you're doing something, you're focused on it. So during my law school, I would go to work 8 to 4, and then I do my job, I'm productive in those hours, and then I hit the class. And for the 3 hours of class, I am there for the class. So I'm paying attention, I'm participating, because that's what you need to do. Like for one specific task, you have to be focused. If you're in a meeting and this is something you do like school or work, you have to be in that meeting like by all your kind of faculties. Like you're listening, you're participating. Some people just kind of like taking notes. That's not distracting. But I mean, you have to kind of, when you pick something, you have to do it. You have to put your heart in it. I think that's kind of one of the key things you do on the execution level. And with that, you will get less interruptions. So if you know that you're focusing, you're finishing this piece of code right now, you don't look at your phone, you don't text, if someone comes in asking you for something, just you can politely kind of try and say, okay, I'll get back to you later. And all of this could change when you kind of been doing this multiple times with different projects, with different activities. You're going to figure out what works best for you. So you'll identify when you're most productive and when you're least productive, and then you work on those areas. And I think I know we're almost out of time, but one big thing that you have to kind of learn to do is ask for help. This is one of the biggest things that I think it's the last thing on my slides, but I think it's one of the most important things that you need to do. And it's not just about asking for help professionally or kind of like working on your homework with your friends. You have to kind of think of it broadly in a sense that your family can help you. Find a support system that when you need something, you're going to go for those people and ask for help. So professionally, like your teammates can help you with this task. It's taking you too long. You need to figure this out. You should ask. At home, you have a supportive family or you have supportive friends. If you even need to talk, oh, I have all this going on. Can you help me do this? With that, I think we are, again, use your own judgment on all of those mentoring slides. But I hope some of it was helpful. Yeah.
Oh, that was amazing. You had such great advice and so much of it. Oh, my gosh. I wish I would have had it years and years ago. That was really great. So we are almost out of time, but I'm going to wrap up with the last few slides here, and then we'll move into some questions. I'm going to ask two of the questions that came in for you to answer online, and then we'll move into the chat room after that. So first I want to remind people we really need feedback on these webinars, so that if you have suggested speakers or topics or things that could be changed, please fill out the survey at the end. This is what helps us make these even better every time and gives us great ideas for speakers and topics. And mark your calendars for the next person up in February is our next webinar. And it's Veronica from the Oak Ridge National Lab. She's going to be talking about high-performance computing careers. So that will be a big change from what we have here today. And lastly, there are lots of other resources at CRA-W, which is the organization that's actually sponsoring this. And so I'm going to leave this slide up while I ask Taghrid some of the questions that have come in. So one of the questions says, thank you for sharing your expertise, Taghrid. Do you have any advice on what us undergrad students can do to try to figure out a research area of interest? I'm considering finding a job at a research institute working for a couple years before.
Actually, what you're thinking of is actually you have the right idea. If you haven't done research as an undergrad, that's a good place to start. One thing I want to say is that if you get a job in research, keep evaluating your kind of priorities or your goal every year. Like you're taking a job, you might end up not getting your PhD, so that's fine too. One thing you could do is kind of participate in research for the undergraduate programs, whether it's in your school or other schools, and I know a lot of the programs are funded by NSF. They might be on the resources for CRA-W. The other thing is look for classes that kind of cover some of the areas you might be interested in. And many of the classes, if you have the option of like doing a research project or doing an exam, you might want to pick the research project. And your area of interest will change, I think. Sometimes you kind of do your research and then dive into a different area. That's fine too. I feel like I'm not giving you a concrete advice on this, but I think like taking a class that might interest you, so that's one thing. Find a program that might have research for undergrads, and actually finding a job at a research institute is a big, that's a very useful one too. Mm-hmm. And let me just add one thing that's kind of, don't think that if you do your research or your graduate degree in one area, you're going to do it for life, or at least for me that wasn't the case, so that's fine too.
Right. The answers. Okay, so CRA-W also has some summer research opportunities. If you go to their site for the DREU, D-R-E-U, there are lots of ways to get summer funded research opportunities if you don't have them at your own school. The last question we're going to ask online is, what skills do you think are important for grad students to have?
So I'm going to say this was one advice I kind of heard from someone, I actually don't remember and at that time I didn't think of it that much, but as I kind of went through my PhD program, it turns out this is the most useful advice. I'm kind of, because you're not going to expect it, it's like persistence. You have to be persistent.
I've heard that a lot.
Yeah, right? Okay. But I think as a student, I didn't get it. And I think if I want to rephrase it, you could say like, follow through. That's being persistent. You take on something and you kind of follow through and then finish it. Even if you don't like it at the end and you want to change, that's fine. Because following through is what can have you, even if you get a job that you don't like, you're going to do the job until you find something better. You're going to finish this research assignment even if you don't like it, and even if the group is not what you hoped for, but you get things done. And having the reputation of getting things done is actually very, very important.
Yeah, that's great. Okay, so we're going to move on into the online chat. So the Q&A will go away, and what you all want to do is start sending questions through the chat, and then you'll be chatting with Taghrid and myself. And thank you very much, Taghrid, for this. This was great. Thank you.
Thank you.
Time.